Okay, so you've seen the ads, right? You've scrolled past the apps, and they're all promising pretty much the same thing. A sharper mind, a better memory, maybe even a genius-level IQ. But is it really possible to train your brain like a muscle? Well, that is the multi-million-dollar question we are tackling today. It's a really tempting promise, isn't it? This idea that just a few minutes a day playing what honestly feel like pretty simple games could unlock some kind of hidden potential in your brain. And let's be honest, we all want that edge, that little bit of extra mental sharpness in our lives. And a whole industry, a massive one, has been built on this desire. You've got companies promising to boost your IQ, sharpen your focus, improve your memory, all with just a few taps on your phone every day. But when you look past all the shiny marketing, does the science actually back any of it up? Well, this is where the story gets interesting. When researchers actually put these claims to the test, the cracks started to show, and they showed up fast. A major study found that these commercial brain training games were no more effective than just playing regular video games, and it gets worse. One of the biggest names in the game, Lumosity, was hit with a $2 million fine from the Federal Trade Commission for making claims the science just couldn't support. Ouch. This right here, this question from a Reddit user just perfectly nails the core issue. Think about it. You can do bicep curls all day long. You'll get incredibly strong biceps for sure. But is that going to help your squats? Not a chance. This analogy is brilliant because it illustrates the central problem with a lot of brain training. Yeah, you get better at the specific mental exercise, but does that strength actually carry over to anything useful? So this problem, this idea of skills not carrying over, it actually has a name in cognitive science. It's called learning transfer. And, this is kind of the holy grail of all education and learning. The real goal isn't just to get good at a task in an app, it's to be able to use that skill out in the messy, unpredictable, real world. So the billion-dollar question remains, do these brain games actually transfer? It turns out there are two types of transfer we need to talk about. First, there's near transfer. This is pretty straightforward. It just means you get better at the game you're playing, or maybe a super similar one. And hey, brain training apps are great at this. Your score goes up, you beat your personal best, you feel good. That part is absolutely proven. But the big promise, the one they sell you on, is far transfer. That's the idea that tapping shapes on a screen is somehow going to make you better at your job or help you ace a calculus exam. And that is the claim that has remained stubbornly, frustratingly unproven. Okay, so if the shortcuts don't really work, what does? What really separates a total novice from an expert in any field? Is it just that some people have bigger, faster brains? Well, the research points to a much, much more interesting answer. Turns out it's not about raw mental horsepower. It's about the library you've built in your head. Experts aren't necessarily smarter in some general abstract sense. What they've done over thousands of hours is build this vast and, this is the crucial part, a highly organized mental database in their specific field. The structure, you see, is everything. And this example just illustrates the difference perfectly. A study showed that if you give a bunch of physics problems to novices and to experts, they sort them in completely different ways. The novices, they group them by what they look like on the surface. Oh, okay, these are all problems with ramps. But the experts, they see right through all that surface stuff to the deep underlying principle. They'll say, these are all problems that can be solved using the conservation of energy. It's like they're seeing a totally different reality. Think of it like a mental filing cabinet. An expert's brain isn't just a random pile of facts. It is meticulously organized into what scientists call chunks. These are groups of information that are so tightly bound together, they can be pulled up as a single unit. It's this structure that lets them see patterns a novice would miss and pull out exactly what they need right when they need it with incredible speed and efficiency. So, if the real goal is to build this rich, structured mental library and not just get a high score on some game, what's the engine that actually builds it? What's the cognitive tool we use to connect ideas and create these deep, powerful structures in our minds? The answer, according to a whole lot of cognitive scientists, is analogy. A Stanford lecturer put it just beautifully. Analogy is the motor of the car of thought. It's not just a clever trick for English class. It might just be the fundamental way we understand anything new, by relating it to something old that we already get. Now, analogical reasoning isn't about noticing superficial stuff, like saying an orange and a basketball are similar just because they're both round. No, it's way deeper than that. It's about recognizing the same underlying relational structure in totally different contexts. It's about seeing the system, not just the stuff. Let's look at a classic example. Two sisters both want the last orange. The simple, obvious solution is to just cut it in half, right? But if you use analogical reasoning, you first see the core structure here. Two parties, one resource, conflicting desires. That structure might remind you of, say, a business negotiation you read about, where the winning solution wasn't to split everything 50-50, but to figure out why each party wanted what they wanted. So you transfer that solution. You ask the sisters, and you find out one wants the peel to bake a cake, and the other wants the fruit to make juice. And just like that, the perfect solution appears. One gets all the peel, the other gets all the fruit. Everybody wins. That, right there, is the power of analogy. And listen, this isn't just for solving arguments about oranges. This cognitive process is at the very heart of pretty much all human progress. It's how scientists have breakthroughs by seeing a new problem as an old one in disguise. It's how we generate creative ideas. It is the engine of that far transfer we were talking about. So, finally, we get to the real question. If this is the skill we actually want, if this is the thing that makes us smarter in a meaningful way, how do we get better at it? How do we build that mental library of structures that we can then apply to new problems? The answer from the research is pretty clear. It's something called deliberate practice. And this isn't just mindlessly repeating something over and over. It is methodical, it is focused, and honestly, it's often pretty uncomfortable. It's about identifying a very specific part of a skill you're weak at, and then designing a practice to target and improve just that one thing, constantly pushing yourself just a little bit beyond what's easy. So how do you actually put this into practice? First, always be on the hunt for the deep principles. Don't just memorize things, ask why they work. Second, use active recall. Instead of just rereading your notes, close the book and try to explain the concept out loud. Forcing your brain to pull information out is what builds strong connections. Third, become a collector of analogies and mental models from totally different fields. This builds an amazing, versatile toolkit for solving problems. And finally, always connect what you're learning to what you already know. That creates a strong scaffold for new knowledge to stick. So I guess the ultimate takeaway is this. Getting a high score in a brain game feels good, but it's a closed loop. The real world, that's a wide open system of interconnected problems. So the question to ask yourself isn't just, am I getting better at this game? It's, am I learning to see the solution?